bits of ClojureScript, not really in a usual ranty mood today. Could I see my slides, please? Okay, so the title of my talk is Progressive Web Apps in Clojure and ClojureScript, or how I learned to stop worrying about everything and just isomorphic everything, right? And so my name is Tejas. I'm Chief Production Crasher at Quintype. We're a publisher technology platform. We do a lot of Clojure. We don't do so much ClojureScript right now. This was actually something I've been working on. But yeah, and we're located in Bangalore, and we're recruiting if anyone's interested. Okay, so in the grand tradition of Clojure libraries, we begin with the irrelevant quote. So I found this on the GitHub page for one of the libraries I'm using quite a lot. So I'm actually giving you an irrelevant quote about irrelevant quotes. So if there's a contest for being meta, I think I win. I know it's early in the day. So progressive web apps, are they a threat or a menace, or like are they just super amazing and there's something we need to everyone needs to know about? So in this talk, I'm going to talk a lot about HTML5, service workers, and progressive web apps. I'm also going to be talking a lot about Clojure and ClojureScript. And what I'm going to focus a lot on is really how do you get Clojure and ClojureScript to sort of work together, reducing duplication across them. That means trying to share as much code as possible, trying to be declarative in the apps that you're building, to not write a lot of boilerplate. And so explicitly, I will not cover a lot of things like build tools and things like that. I do have a GitHub repository where I've pushed everything. I'll show that in a future slide. And you can find a lot of the plumbing over there. For example, I'm using line CLJS build, although personally I would have liked to have moved this to Gulp by the time we finish this talk. Anyway, so before I move further, I'm going to actually show you the progressive web app that I built, so everyone understands why we want to build this. So I'm going to start. What you can see on your screen is an Android phone. Let's see. Can I play this like this? So okay, sorry. Okay, so I'm going to first start by opening up Chrome, and I go to my progressive web app. You'll see it's HTTPS, and the first render itself is nothing exceptional. All I see is I'm going to see a bunch of characters from a popular TV show, The Game of Thrones. This itself is pretty normal. This is what people are used to when they go to the web. So what I'm going to do now, this app also has a menu with a few important characters. And you can also see that each of these characters has a little button saying download next to it, right? And I'll speak about that a little bit later. And you can click through and see the profile page of many of these characters. So what I'm going to do now is I'm going to close everything and switch my phone into airplane mode. Okay, and I'm going to go back to Chrome, and I'm first going to prove that this is in airplane mode, and you can see you're completely offline. And then finally, I'm going to go back to my URL. You'll see even though this app is your phone is completely in airplane mode, this app works completely normally. Any of the characters that you've downloaded, you can now click on them and see their profile page as well. And even if somehow you land on a URL that's not been cached, as you can see, I'm going to change the URL to just something unknown, a valid URL, but something that's unknown. You'll see that instead of seeing an ugly could not connect to server or something else, you'll actually see like a bunch of gears. I mean, some page that's in your control. And finally, when I come back to my app, say after a week or say after a day, let's say I'm a regular user of this app, you'll see that Android offers me a helpful button saying add to the home screen. So when I click this, you'll see now that this is now an app that's on my home screen. And when I click it, you can see it loads with a great splash page. Again, works completely offline. functionality like the menu, things like that. All this completely works, right? Sorry, I'm just gonna get a bottle of water. Sorry. Yeah, so that is our progressive web app. So you can see there's a lot of functionality that you don't get with a regular, just a plain old vanilla website. So before I get started too much, you could have guessed this is a Game of Thrones themed progressive web app. The code is available here. It's deployed at this link. I'll probably upload my slides somewhere so you can download it. Later. Okay, so first I'm going to speak a little bit about progressive web apps before we get on to the nice Clojure bits, right? So I'm going to explain a little bit about why we're building this, right? So first, I'm going to kind of break that up into 3 words. So progressive is as in progressive rendering. What this means is browsers without JavaScript have to get a static page. Browsers that have JavaScript but no service worker get a regular web app. Browsers with service worker get an offline mode. And Android apps, as you can see, can make use of this offline mode. So why it's called progressive is because your app kind of gracefully degrades to the various different levels, right? Progressive web. Now web, because I've only written HTML, CSS, and JavaScript. There's no magic component. There's no native programming required for this, right? And finally, it's an app because it's an app, right? So progressive web apps are HTTPS only, and they're an open standard built on HTML5. So as you can see, the primary extra benefits is it's app-like. You can actually do push notifications as well. They work offline, and you get a splash screen and other functionality to make it look native. So with all of this, as you can imagine, isomorphism is a very, very important concept towards building your progressive web app. You do not, because your app needs to fall back very gracefully, so it renders both on the server side and on the client side. You need to ensure both your backend and your front end work in tandem without duplicating, right? I don't want to remake all my views for my server and then do it again for the client. I don't want to have different crazy mappings for what kind of data exists. Which is why Clojure is sort of the perfect fit, because other than JavaScript, who is the only other people speaking a lot about this sort of isomorphism, Clojure is the only other language that immediately comes to mind, which has both a first-class first-class version, both on the back end with the JVM or the CLR, and on the front end on the JavaScript VM, right? So I was a bit scared after I submitted this talk, because this talk sort of started out as vaporware, but it ended up as sort of a mini framework. This is a work in progress, and thanks to this talk, I sort of accelerated. Okay, so let's speak about the various pieces of the puzzle, right? So this is the flow that most people are used to with web programming. So you have a browser, for example, Chrome, and you have a server, right? So the browser says, hey, give me this page. And the server says, yeah, fine, here's some HTML, CSS, and JavaScript. And the browser just runs that JavaScript. So what happens now is that your JavaScript says, hey, by the way, here's my friend, the service worker. Can you run this person as well? And the browser, assuming it has the capabilities, agrees. And so the service worker appears on the stage. What happens after that, however, is that the service worker sort of takes over your entire network, right? The service worker becomes a proxy that sits in between the browser and the backend server. So from this point on, any HTML requests that are made will come through your service worker. Any AJAX requests that are made comes through your service worker, as does any resources that you load, including images, CSS, JavaScript, including resources from other domains. So at this point, now your service worker has to become incredibly intelligent. And now there's three pieces that are closure based. You have your front-end JavaScript, you have your service worker, and you have your back-end server. All three of them written in Clojure, right? So okay, this is the first bit of Clojure that I'm going to show off. This line doesn't really do anything. It just says, it's just how you register the service worker, which is just service worker.register and the /service worker.js. Okay. So at this point, let's attempt to break down and tackle all the problems that you'll have when you're trying to build an app in an isomorphic way. So the first thing that we talk about is isomorphic routing, right? In a progressive web app, you'll typically view your application as a shell plus data equals a view, right? This kind of corresponds to the purple pattern, which is in essence push the critical resources, pre-render, lazy load remaining data, and fetch it, and show what's required when it's needed, right? So let's first start out by handling a very, very simple question. This route that I'm going to, does this route have a progressive page or not? Because if I do need to show a progressive page, what I want to do is first show the shell and then move on to the actual page, right? So the way I view it, your app probably has three sorts of routes. The first is the progressive web app routes. These are pages for which you have a progressive page. There's the data routes, for example, /API. Typically, these are GET requests, where you're trying to load data for your progressive page. And finally, of course, you have your routes which are only on the server, which are server only. For example, post requests or robots.txt, things like that, right? So what I've been trying to use and what I like a lot personally is BD. BD stands for bidirectional routing, and it takes the approach that routes are data and data can be mapped back to routes. So over here, you can what I'm doing is I first define a set of progressive web app routes. You can see there's just two routes. There's a home page and a character page. The character page requires a character IDs, which is why there's this exists. And also I define API routes, which again has an index of characters, and again you can get an individual character. So my server side looks pretty straightforward. All I have to do is I load each of these routes, and for each of these routes I have a different type of handler. So for all my PWA routes, I have a PWA handler which knows how to render progressive web apps pages effectively. And for all my API, I have a second handler, and for other miscellaneous things, I have a miscellaneous sort of handler. So everyone's kind of familiar with this. This is how routing typically works in Clojure. Now let's look at the Clojure script aspect of it. Now remember, the only thing we want to focus on here is how do we reduce duplication and get the service worker to render your shell before the app itself loads. So we start by just registering the service worker on the fetch. That's the first line. That's the first line of code. Sorry, these line numbers have gotten chopped off. So let's now look at the second function, which is the fetch event. So what I'm going to do is I'm first going to look at the host name of what I'm trying to fetch, and you can see if I'm trying to fetch a page from the PWA Clojure page, what I call is this function, which is called fetch page or cached. And what this function does is it just looks up your BD routes, right? Now my BD routes have been defined in a CLJC file, which means that both Clojure and Clojure script have equal access to this routes file. So what this does is it just looks up and says in this and uses the same BD even on the CLJS side and says yes, this is a page for which we have a PWA, and down here you can, or I can show it on the next slide as well. And then over here just renders the shell instead of making a request to the server. You can see over here, this is the line where I access the cache, which is js/caches. I check if there's a match for /shell.html, and if there is, I just render it. If not, I make a backend fetch to the server. As you can see from the syntax, this relies quite heavily on service worker itself relies quite heavily on JavaScript promises. I didn't bother wrapping it too much because, quite frankly, it's still readable even like this, which is so it actually looked rather nice. So we've now effectively solved the problem of should we show the shell? What about the shell itself? So this we handle in the service worker install process. When we hook in saying that when we try to install the service worker, run this function, and what this does is it just opens a cache and then adds all of these items to the cache. So you can see the items that are added to the cache. There's, it loads the main.js, the main.css. There's a background image, the gears that you saw on the page. I'm also caching an API route just because a lot of people will come to the home page, so I expect that that's something that should be cached. And you can see over here that I'm able to even cache resources from completely different domains. Over here I'm caching a Google font. So this makes sure that my CSS is entirely complete, and when I'm completely offline I can still view my page. So I just want to give a little side note over here. So I think it was Phil Carlton who said, there's two hard things in computer science: cache invalidation, naming things, and off by one errors. Cache invalidation is not handled for you by the service worker. You can see that when I was writing things into the cache, I didn't give it any timeout. This is actually somewhat by design by the service worker. It's cached indefinitely. You need to handle that out of band. Okay, so now let's look at the overall flow of an application. We've now figured out, is this page a progressive page or not? Now let's look at the flow for rendering the majority of these pages. Okay. So there are three ways to load this page. You render the page cold from the server. That's your server side only. You jump from one page to another, and the last is you do a progressive web app, which is you start with the shell and then you load the page. Even when you're loading the page cold from the server, what you'll probably do next is you'll fetch some data from the server and you'll re-render it client side, right? That's the entire isomorphic aspect of this, right? So all of these situations, the flow fundamentally remains the same. So you figure out which page you want to show, determine what data is needed, load it, and finally render the correct view, which I'll call a component because whatever, I'm using in my example React on the background, right? So let's look at this sort of as pseudocode and actually coming from the app. So the top half of the top above this fold is Clojure, and below it is Clojure script, right? And you can see that I'll kind of just read out the first two functions, and you'll see that they're almost exactly the same, just accounting for some Clojure script quirks. So to start with, the PWA page function, it first looks up what are the data requirements of this page. It calls data/load data, which will load the data requirements. It takes the data requirements and passes it to this function, finally creates a component with that function and renders it, right? And the Clojure script version of this function behaves very, very similarly, in the sense that it does the first step is exactly the same. It figures out what's the data requirements of the function. It then loads the data, and the only difference here is that instead of synchronously loading the data and then rendering a page, we do what the client side does sort of best, and loads data asynchronously and passing it a callback which will finally update your application's state. And I'll talk about a lot of this later, but the first bit of the pseudocode I want to speak about is isomorphic data loading, right? How do I make sure that without too much of duplication, my client understands what data it needs, and the server can provide this data to me, right? So first of all, I just want to call out a caveat is that I'm using JSON everywhere. I've seen a lot of people doing Clojure and Clojure script together and passing along EDN or CLJ on the wire. I would recommend against that to some extent, and maybe we could talk about that a little bit later. Okay, so back to where I was. So what I've basically defined over here, I wanted to sort of do this data loading in an entirely declarative way. So what I've defined over here in that first section where you see def pages is I'm going to now specify what are the data requirements for all the various pages, right? So for the home page, the data requirements that I need is a list of all the characters. And for the character page, I need this specific character with that specific character ID. And this becomes the data. This becomes my declarative way of specifying that for this progressive page, these are the array of data that you need to load, right? So coming to the server side, how does the server side handle all the various data? Is that you can see over here I have the handler for loading a particular character. The load data function itself just looks at what data do you need and dispatches to the correct to the correct data handler. And for example, the one that loads the character will do an API call and does a little bit of bunging. It's a backend API. I don't want to go too much into what it sort of does, but you can see here this is where you would put your loading logic. This is where you put your bits that loads your data. And on the client side, what I want to do over here is I want to use BIDI again to kind of figure out what data I want, right? Now remember when I spoke about BIDI first, it was bidirectional routing, which means you can go from a URL to parameters, but you can go from parameters back to URLs as well. So my thought was, why not use this to kind of figure out what data is to be loaded. So over here, so obviously if I have a route /API/character/42, I know that what I want to I have to load the character handler, and there's a param saying character 42. But what I want to do here is, if I say where can I find the character whose character ID is 42, this should tell me /API/characters/42. So now in this example, BIDI has given me a way for on the client to figure out where my data should come from. And I'm using this quite a bit. So you can see this is my load data function. So the first line is figure out the path for where I need to get this data from, and then try to get it from the cache. The cache, of course, just does what we've seen before, which is kind of opens the cache, tries to fetch it, and if it's in the cache, render it turn it from a response object to CLJS, or otherwise just fetch it from the cache, which, as you know, basically, which takes the response, clones it, and puts it into the cache. So in this way, what I do is when I make a GET request, I implicitly automatically cache it, so that the next time people are coming for this resource, it's automatically just served from the cache, and so it can be served a lot faster. Just FYI, I think the Washington Post was probably the first people to kind of roll this out in a big way. And what they were saying is to go from like the home page to the story page, they were getting a fully loaded page in roughly 85 milliseconds. So as you can imagine, this is probably the way to get your websites to be a lot faster in the future. Of course, they weren't doing ClojureScript. I should call that out. Okay, so yeah, so that brings us to the end of this isomorphic data loading. The key that I did over here as well, just to briefly summarize, is that I wanted to kind of use BIDI to figure out where is this data that I need to load, and then load it on the client side. The server side is what will be the one that uses that same handler to actually load the data from its backend resource. Okay, so what I want to speak about next is how do you manage application state. Now, if you remember this slide that I just showed, over here I mentioned that this changes the application state. So in the tradition of Clojure, we want to kind of keep everything as immutable as possible. We don't want to have to deal with state as much as possible, and let all our components and all our views be completely pure, and manage state sort of at an outside layer. So for this, I kind of took a lot of inspiration from Redux, which is one of the popular frameworks. So what this says is that your application state is fundamentally a single atom. And who listens on this? Your components and the browser listen to this application state. And actions from the browser will call callbacks, which change your application state and causes everything to be rebound. So what are the sort of things that we can have that listen on this application state? So over here, I'm just showing you a few things that that kind of take this philosophy a little bit forward. So the first one is just the definition of the application state. Okay, so let me just go back. As you can see, the application state has a handler, a data, the current URL, and the title. Okay, so once again, we define the application state. So using add watch, we first we want the application state to closely mirror not only the state of what's in the page, but the state of the browser as well, right? Which means that we want to do things like when you click back on the browser button, it should sort of roll back your state to where it was before. And when you change the title or the URL in a state, you want that to reflect in the browser's address bar as well as the browser's title. So you can see the way we can accomplish that is to add a watch on the application state. And in essence, when I say is when the old title is not the same as the new title, do an update title on the browser. And similarly, when the URL has changed, do a browser push state or do a browser replace state, which changes the actual address of the browser in the notification bar. And finally, what I'll also wire up is that when you click the back button on the browser, what it does is it actually calls a Clojure callback, which will move to the appropriate page based on the route. Yeah, and finally, you'll see that starting your application is just the same call, which is moving to that particular page based on the current path and loading the page. And yeah, and the most important thing that also listens on this application state is my main component as well. I'm treating everything that's within a shell as one single immutable component, and here I wrap it in a mutable component. So the core component itself is immutable, and I wrap it in a mutable component which listens to this atom. So that's what this rum/reactive means. It just calls my component, calling with the handler of the state and the data of the state. And this rum/react tells this component that when this atom updates, please re-render this particular reactive component. I've chosen rum for this example because it's a really simple, easy to understand wrapper over React for ClojureScript, but you could also use Ohm or Reagent or any of the other libraries. So the last topic I'm going to be speaking about is the isomorphic rendering, and I think till now this is probably the one that's the best explored. So as I mentioned, I'm going to be using rum because it's easy. And so sorry, I have a typo over there, but I wanted to say that if you're still using CLJX, for the people who are actually doing ClojureScript, don't use CLJX anymore. It's Clojure 1.7 includes reader conditionals, which lets you define different blocks which are used in Clojure, ClojureScript, and whatever. You should be using that instead of CLJX. So now let's kind of expand our declarative block that we had over there. Earlier, the home page just had a data function explaining what is the data requirements for this page. I'm now adding a title function to change the title of the browser, and I'm adding the component, right? What is the main component that I'm going to render on this page? So in this case, you can see that the home page renders the home component, and the character page renders the character component. And similar to the closure script, I just have one large wrapper around this, which in essence just chooses the correct component and renders it. The components itself are pretty simple to understand. You can see that this is the navigation component. That's the menu that dropped by. You can see this syntax is in essence hiccup syntax. It easily lets you define classes, stuff like that, and your view's been defined. The first two lines you can see are where I'm using a reader conditional. You can see that over there what I'm saying is that def navigate. This navigate function exists on the client side because when you click a link, it needs to load the new page in JavaScript. But this doesn't exist on the server side. So you can see that the first two lines is where I'm short circuiting all of these functions. So on ClojureScript, the navigate function will go to action/navigate, and the download character goes to action/download character. But on the server side, this is just constantly nil, which still lets my app compile correctly and render correctly. So this is the navigation page, and this is for example the character thing, which basically does a map over the characters. I think that bit's been chopped off, and just renders a page for each of the characters. So the components themselves are pretty simple to build. The overall layout is also incredibly simple. It's again defined here, and you can see that I also need to handle my SEO fields and my SEO data and stuff like that. So this is kind of the overall handler, and you'll see what I do is I render the component, passing in the title as the next parameter, and if I have some SEO data I want to load, I load that as well. Keep in mind that concepts like the SEO data and stuff like that are entirely server side only. They don't exist as concepts in the JavaScript typically. So which is why I just wanted to kind of call that out, even if it's not too relevant. And you can see I defined two containers. There's for two different React components. So I first have a header container where I render the navigation component, and on the client side I have and in the body I have a container where I render the other component. And on the ClojureScript side, we just we mount the main component into the container, and we mount the main navigation into the header container. So in this sense, these two just kind of get mounted, and they override the existing app. And once again, I'm just calling out that all I needed over here is I just have on the ClojureScript side one kind of wrapper component which is responsible for listening to the application state and updating things. So that kind of helps make it a little bit separating concerns. Okay, so what's missing is that, as you can imagine, this doesn't necessarily look the closest to HTML that it is, but I think that's there have been some attempts in ClojureScript to kind of build a slightly better language. I think one that's popular is NLive. It's not something I particularly am fond of, though, for various other reasons. But yeah, that for me is probably the one missing component that would that stopped me from being super productive in ClojureScript. So if anyone's looking for an open source project to work on, yeah, a templating language that would work with ClojureScript and Hiccup, that would be awesome. Okay, and the very last topic I'm going to speak about, I'm running I think about 5-6 minutes early, is the manifest. So the manifest is just the last bit of it, nothing to do with Clojure or ClojureScript, but the manifest just tells you that, hey, this app can be promoted from the browser into a main app. There's nothing really special about it. It just tells you the name, what the background color should look like, where your icon comes from, stuff like that. But so this file is the one that tells you that this can be promoted. There's of course all the various caveats, such as the service worker should always has to be in the root of your web server, because anything that's a subdirectory of the of the service worker will become part of your progressive page. So there are all those caveats. I'm not really going to cover that. It's all in miscellaneous. But some things I wanted to maybe just call out. The shell itself is a reactive component, really just empty. I started in CSS. An entire so I mentioned before that you don't the individual items in your cache don't get expired. This is mostly true, but the browser will purge the entire cache all at once. So you could see that when we started it, I kind of mentioned cache names like PWA app, PWA data. The PWA app, for example, will usually not, in the PWA data one will get kind of bloated as you keep going on to different pages, and one day the browser will just throw the entire thing out. But the items in the PWA app cache will not get bloated, so will kind of stay around longer. I didn't really. I wish I had spent a bit of time on getting Gulp to fingerprint assets and the service worker. Playing around with service workers is a little bit of a pain because of when they get reloaded. Keep in mind that service workers actually run across tabs. So if you have 4 tabs on the same domain, you'll have one service worker running in the background, and the service worker, you kind of have to force it to get reloaded. It has its own life cycle. And finally, I didn't really handle push notifications, but that can be done too. Okay, and with that, I think I'm coming to the end, and I guess I now have about 5 minutes for questions. Yes. AMP? Yeah. So I think he was asking about what's the relationship with accelerated mobile pages, Google AMP. So Washington Post actually has a very interesting thing over there. Is that what they do is most of their pages are AMP supported, and so when you how many people are familiar with AMP? Let me ask that. Okay, fine. It's about half the audience. So what AMP is when you search for something, like let's say some news story on the Washington Post, you'll see a few Google results in really big letters, and when you click it, it loads the page really fast, and you'll see that the domain itself is google.com. But that's actually only half the story. Washington Post was one of the first to embrace AMP. But what they actually do is when you're looking at the AMP page, they actually load a service worker in the background, which renders the shell of the application. So the next page that you go to from the AMP page is actually not AMP, but it's a progressive web app page. So you're partly right. And actually their 85 milliseconds thing was actually for it was actually for loading the PWA itself, not for the AMP. But Washington Post basically did a two-pronged approach on that, as far as I know. Yeah, but that was a very good point. Yes, you could use this in conjecture with accelerated mobile pages to kind of get even faster.
Hello. Yeah, I would like to ask, why did you use JavaScript promises versus core async? Is there a reason for that?
Well, I could have used core async, except service worker itself, you have to remember that you're integrating with the browser. All the functions that I provide to service worker, like you'll see that the first line of all the service worker, let me just give it. Yeah, so you'll see that the first line is actually a raw JavaScript code, that is add event .add event listener. That .add event listener, the function that I give it actually has to return with the JavaScript promise, right? So even if I was doing core async, what I would be doing is continuously wrapping core async objects, well, channels with promises, and then doing vice versa. And I actually started with that approach, but I found it got more and more unreadable as I went along. And there'll be other problems as well. For example, you'll see that, for example, this JS/fetch. the JavaScript fetch API, which is what a lot of this is built on, it came with the HTML5 spec. That again returns a promise. So it's very, so I was continuously doing a lot of, wrapping and unwrapping. Possibly if your code is getting more and more complex, you could kind of consider investing in a wrapper that just turns core async into promises and vice versa. Any other? There you
go. Hi, I'm working on React mobile apps using Webpack. So how would we do something like dead code elimination, code splitting, or tree shaking, all that Webpack stuff in Clojure?
Okay, so first of all, ClojureScript always gets compiled with Google Clojure, and that's Clojure with a S. So a lot of those things are actually handled, especially like dead code elimination. It actually does remove code that it thinks is unused. But that being said, you can actually replace. So in my example, I'm actually using line CLJS build for compiling things, which means in my project.clj, I specify run these kind of pipelines on this, which is, it kind of says more advanced. But I think for the last year or so, ClojureScript has been self-hosted now, which means that ClojureScript can compile ClojureScript on using the V8 engine, which means that today ClojureScript actually can work with Gulp, right? And I believe there is a Webpack ClojureScript as well, or if not, you could probably write it. But what you would do is you would use the Gulp in ClojureScript, Gulp ClojureScript to kind of compile your ClojureScript to a JavaScript file and then pass it to Webpack, right? Or pass it to Browserify. Yeah, I think you could do Browserify also. Does that answer your question? Unfortunately, I didn't have a good answer for that. So the other thing that Webpack does is it does the splitting, which is basically saying that these files are, create this asset and these files create that other asset. That's definitely something I didn't find a good solution for just yet. What I did in the interim was I just created two folders. I created a service worker folder and a main folder, and then these kind of and these two files just kind of contain the entry points. They would mostly call CLJC files from the main thing. So did that answer your question? Okay. Yeah.
You said you didn't like to use Eden and you prefer to use JSON. Why is that?
Yeah, so definitely across the wire, I found that using non-standard, data transfers kind of cause more problems. So let me sort of give you an example. I think so. We were actually doing a lot of ClojureScript about a year and a half ago. ClojureScript wasn't necessarily the most sort of as friendly as it was right now, and so in the beginning we were transmitting a lot of Eden across the wire. Sorry.
Is that through transit or just Eden?
Frankly, I can't remember right now. I'm not sure if it was transit or if it was by itself. But when we were sending raw, like the primitive objects, it was sort of really fine. But then one day what happened was that someone included a library for, I think it was an unordered set or something like that into our thing. It wasn't it was an ordered set. It wasn't the usual Clojure set. It was an ordered set. And then when that sort of got transmitted over the wire, that sort of got serialized into something a bit strange, and we had to make sure that the reader macro was available on ClojureScript as well. And macros behave a little bit differently in ClojureScript. So we started getting into all those sort of problems where we'd send over one sort of data, and the data that was read on the other side, it was mostly the same. I mean, at the end, it was still a seek of items, but the data didn't behave exactly the same. And so at that point, we were just thinking that, okay, is this really worth the effort instead of just sending over raw data and then just parsing it ourselves? Okay, so that's one. Two is now with these things like like service workers, let's see. No, let me just give me a sec. You'll see that some of the things like JSON serialization, this is sort of done for you as well. So over here you can see I take the response and I call .json on it, which, and maybe to combine these two questions, actually returns a promise with the JSON in it, right? So it makes more sense to kind of do that. So that's answer number 2. Answer number 3 is that as soon as you build an API, you should assume somebody else other than your own client calls it. And I think another mistake that we were doing is I think where we write EDON is I think in our session objects and stuff like that, we were kind of serializing EDON into a cookie and writing it. This turned out to be a big mistake because, you know, if you use HA proxy to kind of, you know, move routes from one server to the other server just cannot look inside this cookie at all, which maybe is a good thing actually if you look at it from big picture, but whatever. It's a door that's closed because closure is the only thing that can read EDON effectively. Does this blinking red light mean I'm completely out of time?
We can take a few more questions. Anyone else? No more questions? All right, let's give him a round of applause. Thank you, Tejas.
Thank you.
Okay, so we've kind of discovered that the tables are a little bit off center. So we're going to realign them. So can I request everyone to please stand up, head out for chai time, conversations. And when you come back, don't sit with your friends, sit somewhere else.